Hello, today we're going to do a test with the two motors and two controllers running at 500 amps. The motors are rated 150 kilowatt each, and the inverters around 200 kilowatt, maybe 250. Cooling is quite good, so yeah, we can push to 500 amps. We will see. The water, we have a water cooling system. Yeah, from there it splits, half goes to the inverter and then exits the second inverter as well, goes to output, and then the path for the water is going to cool the first engine motor, yeah, and the second one, and then goes out. The torque sensor is reading the torque and the speed. We have a display for that here. The signal from the torque sensor as well goes to the power analyzer. So the power analyzer here, it can compute the torque and the speed and then multiply. I input the equations. You can have a menu, you can have a equation input from the menu or from the PC. You can input the equations of the torque times speed divided by 9.55 and then get the mechanical shaft output. Then you have the current sensors and on the faces, and then current sensor on the DC bus, so we can see the efficiency in real time of the generator and then efficiency in real time on the controller as well. Also we have an isolated channel oscilloscope to visualize the DC bus and the commutation from the IGBT. So collector emitter is connected to this one, and then DC bus on the other one to see the ripple. Also we have a scope recorder to record additional signals like DC bus to see if there is a spike event or something like this. You can have everything recorded. You can record 16 channels or all isolated. I have current probes which are not yet attached, not at the moment. So yeah, let's do a test. Also a 400 volt battery pack. We can visualize the current of the battery here. On the PC we are running two instances. So one instance is looking at the first controller, the second instance is looking at the second controller. Let's turn on the water. That's for the motor side, that's for the controller side. Okay, not maximum, you don't need maximum. The efficiency recorded on these motors, it was 98%. They are made a special order for somebody, carbon fiber sleeve, so it's very light for the output power it gives. So it can give continuously about 125 kilowatt, maybe 150 depending on the liquid cooling and the flow. Controllers can also deliver around 500 amps peak continuously basically, and then like 380 RMS at 700 volts the DC bus. Let's do a test. I prepared here the first one so we can start, play. We give some speed. This one is running in motor mode, that one in generator. So this one is spinning, the other one will brake. We have the potentiometer, so we can regulate how much current we want to have. We can look at the battery. So we start loading. We can go all the way to the maximum. $500 amps, 329.26 Newton meters, 503 amps. We check the current, 369 RMS. Yeah, so I reduce the current now. We can stop. The controller temperature 40 degrees, cooling down fast because I have a good cooling, and the motor temperature 61, 58. The generator on the other side. Yeah, this is the setup using vesc software. The controllers can both run in sensorless mode or resolver mode. This motor has a resolver in the back, so it can accept the resolver signals or a custom encoder. I have here a custom encoder. So that's nice. The inputs are CAN bus adapter, and then USB for firmware update, and then the two controllers are on the same DC bus. What you can see there is the battery voltage that comes in, so I'm adding the difference in efficiency from the battery because you need to have a supply. Yeah, controllers. Yeah, current sensors are getting hot as well. Yeah, so that's my setup.